Hi friends, welcome back to Edupedia World. Today's lecture we will study about uniform circular motion. We will understand what uniform circular motion is and what are the forces involved in uniform circular motion. Let us start the lecture. Today's lecture is about uniform circular motion. Uniform circular motion. As the name suggests, uniform circular motion is motion in circle and something is uniform about it. What is uniform? The fact that its speed is constant. So, uniform circular motion is motion of a particle of a particle in a circular path at a constant speed. A very important point to remember here is that the speed is constant, not the velocity. So uniform circular motion is motion in circular path at a constant speed. Why do I say that the speed is constant and not the velocity? I say so because velocity depends on the direction of motion, and in circular motion the direction of motion is constantly changing. Motion is in a circle, so if the motion is in anti-clockwise direction, then the direction of motion is in this direction when it is here, and it is in some other direction when the position of the particle changes. So we can say safely that the velocity is not constant. And what do we know about a motion in which the velocity is not constant? We know that then the motion is an accelerated motion. Therefore, a uniform circular motion is a motion under acceleration. It is a accelerated motion, and it is not constant velocity. Though the magnitude of velocity, that is the speed, is constant, the direction changes. And since the direction changes, the velocity changes. Now what can we say about the direction of velocity at any given point? The direction of velocity for a uniform circular motion at any given point is the tangent at that point. So here it is the tangent, here it is the tangent like this. What does tangent mean? It means that if we draw a line from the center to the point, then that will make a 90-degree with the direction of velocity. We saw that the uniform circular motion is an accelerated motion, and we know that for any acceleration to occur, there has to be a force. Therefore, uniform circular motion has some force which results in the circular motion. Now, what is that force? That force is called as the centripetal force. Centripetal Centripetal, centripetal force. Centripetal force is a force which is acting towards the center, towards the center. Why towards the center? Because in this case, in the case of circular motion, if there was no force and if the particle was over here, then the particle would have continued to move in this straight path. But since there is a force acting towards the center, it makes the particle move towards the center. As a result, it follows the circular path. So obviously the force is trying to bring the particle towards the center. An interesting aspect about the force in case of circular motion is that the direction of force is always towards the center. Therefore, the direction of force is continuously changing. When the particle is here, the direction of force is directed this way. When the particle is here, the direction of force is directed this way. It's always towards the center. As a result, what we can say is that even in uniform circular motion, the acceleration is also continuously changing. Why? Because acceleration also depends on direction in addition to the magnitude. Therefore, in uniform circular motion, the velocity is constantly changing and the acceleration is also constantly changing. Now, what is the centripetal force in different scenarios? We'll see some examples. The example of the Earth revolving around the Sun. This is the Sun and the Earth is revolving around the Sun in a circular path. This is the Earth. Now, why does it circle in the circular path? This is because there is a force of gravitation. Gravity is pulling Earth towards the Sun, and this force of gravitation provides the centripetal force necessary for the circular motion. In the example of an atom, suppose this is the nucleus of the atom, and the electron revolves around the nucleus in a circular path. Where does the centripetal force come in this example? This comes from the electrostatic force of attraction. The electron is attracted towards the nucleus by electrostatic force, and that force provides the necessary centripetal force for revolving around the nucleus. Now imagine you have a rope and a stone tied at the other end of the rope. You have a stone tied end of the rope and you are holding it here and you are revolving it in a circular path. You might have done this many times. In this case, again we have a circular motion, so there has to be a centripetal force. That centripetal force is the tension force in the string. So there is a tension force in the string which is pulling the rock or the stone towards your hand, and that provides the necessary centripetal force for the circular motion to take place. There is another force which is discussed when we discuss about circular motion, and that is called centrifugal force. Centrifugal force. Centrifugal force is not a real force. It is actually a fictitious force which is used to describe the complete scenario. We are not going to discuss when it is used. It is beyond the scope of the syllabus. But all you need to know, it is not a real force. Not a real force. What is it? It is a force, a fictitious force acting away from the center, acting away from the center of the circular path. So centrifugal force is basically the force opposite to centripetal force, and it is not a real force. It is a fictitious force which is used to explain the whole circular motion in its complete sense, but we are not going to discuss. The only thing in scope of our syllabus is that it is a fictitious force and it is applicable opposite to the centripetal force. That is, the centrifugal force for this case will be in this direction, for this case will be in this direction, for this in this direction. So in this exercise, in this chapter, we read about circular motion. We did not go into very details, but we have some idea about what circular motion is, what are the specific features, that it is a constant speed, not a constant velocity motion, that it is a motion under acceleration. We read about centripetal force, the force necessary to provide the acceleration, and about centrifugal force, which is a fictitious force. With this lecture today, we come to a conclusion of our series of lectures on force. From the next lecture, we will be discussing about work, energy, and power. I hope you had fun learning about force. Hope to see you in our next lecture. Till then, have a great day. Goodbye.